everybody, I'm going to solve inequalities. We're going to look at multi-step. So I've done a very, very basic inequalities video, how to read them and graph them. I've done solving inequalities one step, and now I'm going to look at multi-step, and there are going to be some special cases in here. So we're going to solve the following inequalities and graph their solutions. So this is probably going to be the last video in my series here. So if you haven't seen my previous ones on inequalities, go ahead and watch those if you don't know what you're doing before you watch this one. So again, we're just going to solve this just like it's an equation. We just have to be mindful it is an inequality. There's going to be usually more than one solution, but not all the time. And we have to be careful of multiplying and dividing by a negative number. So I'm going to work the order of operations backwards. Going to focus on my x, which is on the left side. So I got to get rid of the -3. I got to get rid of the 7 to get this x by itself. So if I'm working the order of operations backwards, I got to move this 7 to the other side. So I'm going to subtract 7, subtract 7. When I do that, -3x is still going to be there. 7s are gone. Since I'm just subtracting here, we do not flip the inequality, leave it alone. And on the right side, I have -8 minus 7, which is -15. Got to keep going. Got to try and get x by itself. Got to get rid of this -3, so we're going to divide by -3, divide by -3. When we do that, these -3s are gone, and I just have an x here. But notice, I just divided both sides by a negative number. When I do that, we need to flip it the inequality and open it the other way. On the right side, -15 divided by -3 is +5. So if I'm graphing this, I'm going to go to 5. I'm going to have an open circle. And I'm going to plug in 0. 0 is always the easiest number to use. Plug in a 0. If this inequality statement is true, we're going to shade towards the 0, which would be to the left. If it is false, we're going to go away from the 0, which would be to the right. So I have 0 is greater than 5, which that is false. 0 is not greater than 5. So I need to go away from the 0, which is to the right. Now, what does that all mean? It means anything that is shaded here is a solution to the original problem. So 5 is not a filled-in circle. So 5 wouldn't work, but 6, 7, 8, 9, 10, all those are in the shaded area. So if I took 9 and plug it in, I'm going to get a true inequality. And it's going to happen for all of these numbers in this direction. Okay? So let's move on to another example. So I have 2 parentheses, x minus 3 is less than or equal to 2x plus 7. A lot going on here. Still using those basic solving skills we use when we're solving equations. So first thing I'll do is when I see parentheses, I'm going to distribute here. I'm going to multiply this 2 all the way through. So I'm going to take 2 times x, which is 2x. I'm going to take that 2 times that -3. 2 times -3 is -6. So all I was is distributing. Nothing changes with the inequality. Nothing changes on the right side. So now I'm ready to solve this. Distributing's done. I do see that I have x's on both the left and the right side. So before I start thinking of doing PEMDAS backwards, the order of operations backwards, I'm going to try and get these x's on the same side. So I'm going to move this 2x to the right side. So I need to bring both the 2 and the x over. So I'm going to subtract 2x over here, which means I got to do it on the right side. But when I do that, 2x minus 2x, that's gone. I have a -6. Since I'm just subtracting, the inequality doesn't change. On the right side, I have 2x minus 2x, which that's gone. And I have a 7. So a lot of people might be startled and think, oh boy, what did I do? I messed up somewhere. You did nothing wrong. This is totally fine. My x's are gone. So trying to get x by itself isn't really going to happen because x is gone. We can actually stop what we're doing right here. And what I have here actually tells me the solutions to this problem. So let's read this. It says -6 is less than or equal to 7. So you got to ask yourself, is -6 less than or equal to -7 or to 7? Yes, it is. This is a true inequality. So what that means is this is one of those special cases. And the special cases are either they're going to have one solution, which is what we're going to have in most part. Well, not one solution. You're going to have a multitude of solutions. You're going to have infinite solutions or no solutions. In this case, -6 is not less than, or sorry, -6 is less than or equal to 7. This is true. So what we get, since this is a true statement, this is infinite solutions. Infinite solutions. What that means is no matter what you plug in, any of these numbers you plug in, you're going to get a true inequality. Therefore, all of these numbers are solutions. So what the graph looks like is the entire thing is a solution. Every single number you can think of is a solution. So you can plug in any of those numbers and you would get a true inequality. A few more problems I want to look at, a few more special cases. So to the back side, I see a 2x minus 9 is greater than or equal to 2x plus 7. So no parentheses there, so I don't need to distribute. If there were parentheses, we would be distributing. I see 2x on the left side, I see 2x on the right side. We got to get those together. So I'm going to subtract 2x and subtract 2x. But when we do that, 2x minus 2x, those are gone, so I get a -9. Since I'm subtracting, the inequality stays the same. On the right side, 2x minus 2x, it's gone, and I get 7. So it's another special case where my x is gone. What does that mean? So I see -9 is greater than or equal to 7. -9 is greater than or equal to 7. I'm going to ask myself, is -9 greater than or equal to 7? No, it's not. That is a false statement. So you got to think, if I'm thinking special cases and I get a false or incorrect statement, what does that mean? What that means is we have no solution. Meaning no matter what you plug in, you're never going to get a true inequality. So actually the graph of this is a completely blank number line. There's nothing shaded, no circles, nothing. So you get no solution there. I'm going to show you one last final example here. So I'm going to try and avoid the special cases and show you, yes, not always do we get infinite solution or no solution. Sometimes you can completely solve these. So I have 7x plus 6 is greater than or equal to 9x minus 2. So I'm going to work through this. Got to get my x's on the same side. I have x's on the left, x's on the right. Before I try and isolate and get x all by itself, we got to get them together. So I'm going to move this 7x to the right side. So I'm going to subtract 7x and subtract 7x. If we do that, 7x minus 7x, that's gone, so we get 6. Since I'm subtracting, that is not going to flip my inequality. On the right side, I have 9x minus 7x, which is 2x, and I still have a minus 2 there. So now I can go about my business, since I have my x's all on the right side, trying to get x by itself. So order of operations backwards. Get rid of the addition subtraction, which means I need to plus 2, plus 2. 6 plus 2 is 8. Since we're adding, no change to the inequality. 2x on the right. Keep going from there. Got to get this x by itself, so got to get rid of the 2. So divide by 2. Divide by 2. 8 divided by 2 is 4. We're divided by a positive number, so nothing changes. So it's greater than or equal to x. So I have 4 is greater than or equal to x. Now we're ready to graph. So I'm going to go to 4. Because it's a greater than or equal to, we're going to have a filled in circle. And then we just have to figure out, do I shade towards the 0 or away from the 0? So I'm going to plug in 0. 4 is greater than or equal to 0. 4 is greater than or equal to 0. That is true. So we're going to go towards the 0, which is to the left. So that concludes this video. I looked at quite a few problems, multi-step problems. Shouldn't be overly difficult. If you know how to solve, even the most complex equations, then solving complex inequalities isn't too bad. Be careful of multiplying and dividing by negatives. And if your variables go completely away, that isn't the end of the world. It just means it's either a no solution or an infinite solution problem. Until next time, solving inequalities, multi-step.